Hey everybody, it's Scott coming at you via the World Wide Web. To those of you at home or those of you who are just reviewing for what's coming up. All right, what we worked on today is we did a little bit of popcorning out where we just called some random students and just talk about, okay, what is kinetic energy? Well, we know it's the energy of motion. Energy transfers from blank to blank, which we know is high to cold, or even, high to low, or even hot to cold. We talked about what happens with the temperature. If something has high kinetic energy, and we know that that's hot. If it has low kinetic energy, it's cold. So we just popcorned out to review some of the ideas that we've been talking about in class. For what we worked on that, which was new, is we looked at remembering our thermometer we made in class where we had our blue dyed water and how we put it in the vial with the stopper and the tube on it, and how when we added it into the hot water, the water went up the tube, and when we had it in cold water, it went down the tube. We kind of talked about why that happened, very basic. But today we're going to be looking at that a little bit more in advance. So thermometers are used to measure temperature. So how can we remove energy from the thermometer? Keep in mind when we talk about this, energy always transfers from high to low or hot to cold. So we talked about in class, well, one way we can remove the energy from the thermometer is by placing it into a cooler substance. So by placing it in cold water, it's taking energy out of the thermometer and putting it into that cold water environment around it. Then we looked at this wonderful thermometer animation. We looked at, first off, what the blue particles are. And we know, looking at our little key over here, those are our water particles. The gray is our glass particles, and the red is the alcohol inside a thermometer. And we've talked about in the past with energy transferring. We haven't talked about it with as many steps as we're looking at today and we're going to be looking at in the future. So if I go ahead and I turn on the Bunsen burner right here, that energy is going to transfer upwards into the water. And as you can see, the energy from the heater transfers to the water molecules. And the water molecules start moving faster. So since our molecules are moving faster, we know that they have a higher kinetic energy and the water inside is heating up. And we looked at where the energy transfer is going to take place next. A lot of students think that the water is going to transfer its energy up into the alcohol right away, but there's a barrier in between. So before it can transfer to the alcohol, the water has to transfer its energy first into the glass particles. So if I click on the next, I want you just to predict what you think is going to happen to the glass particles. Was your prediction correct? Did you think that the glass particles were going to start to move faster? Because if so, you are correct. The faster moving molecules hit the glass thermometer bulb. Energy from the water transfers to the molecules of the glass thermometer bulb, making the molecules move faster in our glass. Then the next step is what's going to happen inside the actual thermometer. You can see we haven't gotten to the alcohol particles yet. When we do, we're going to notice that the alcohol particles are going to speed up. And when they do that, they're going to be moving faster and further apart, which causes our alcohol particles to expand up the thermometer. So let's go ahead and see what that looks like. As they speed up, they start to move further apart, and they travel up the thermometer. And now, what we're going to be looking at here is if I actually cool the water down. So what's going to be the first thing that's impacted if I turn this heater off and it starts to cool down? Well, the first thing that's going to be impacted is the water particles. They're going to slow down. So when the heater is turned off, energy radiates from the water to the environment, so everything around it. The water particles have less kinetic energy and move more slowly. Then we talked about what's the next step, because we always want to think about what's the next step. How is it transferring from what to what? This is where a lot of misconception came in. A lot of people said, well, the cold water or cooler water is going to transfer its energy into the glass. But that's saying that energy goes from low to high. And we know that's not true. So the energy is actually going to transfer from our glass particles into our cold water particles or cooler water particles. And you're going to notice they're going to be going the same speed. So they slow down, they go the same speed. And the next thing that happens is our alcohol does the same thing. It transfers energy into the glass particles, slowing the alcohol particles down, causing them to contract and go down the thermometer. You notice they're all going the same speed here. After that, we did a reading from from the FOSS book. I will post that into the details of this lesson. Have a great day and great evening. Bye.